All right, today we are going to be talking about unit rate, and we're going to start out by going back and looking at what a rate is. And a rate is a comparison of two numbers with different units, and that's different from a ratio. So a rate is going to be like 20 miles to 4 hours, and we've got miles and hours here, and in this example we've got $7 to 3 pounds. We've got dollars compared to pounds. And when I talk about ratios, they actually have the same units. And if you remember from our first learning target when we were working with conversions, when I have the same units, those can cancel out. So you might also have heard it said that they don't have any units. But that is why. It's because they can cancel out because it's the same units. So they're different from a ratio in that they have different units, whereas we were comparing miles to hours with a rate, and ratios we might have been comparing miles to miles or hours to hours. So we would have the same unit that we were comparing. In a unit rate, if you remember, a unit fraction has a 1 in the numerator. In a unit rate, we're going to have a 1 in the denominator. So a unit rate has a denominator of 1. And one key word that you're going to hear is the word per. And per tells us to divide, and it's also going to mean for every 1 or in every, as in one box or in every box. There are so many. And how do we calculate that? Well, we are going to divide. And if you're thinking, why is this useful in real life? Well, I can't tell you the last time I said I went 20 miles in 4 hours. Or somebody said, how fast is your car going? And I said, well, I went 20 miles in 4 hours. Or if I was looking at the price of something and it told me how much it was for 3 pounds. So we're usually looking at what do we want for 1. So this helps us make sense of the relationship between the numbers. And it gets it into simplest form for us that we can look at, oh, I understand what for 1 of something means. So it allows us to make comparisons. So we're going to start with some that you are going to be able to connect to something you've seen in your life. So Sam drives 120 miles in 3 hours. And they want to know how many miles does he drive per hour. So that's how I knew to put the miles over the hours. So any word problem I'm looking at, because they could flip that. They could have said, how many hours does it take to drive 1 mile? So they could flip that. So you always want to look for, this is going to be the top. And then as soon as I see that per, that's like the division sign, the fraction bar. And then the other one is going to go on the bottom, on the denominator. So when I do this, I do 120 divided by 3. And 120 divided by 3 is 40. And then I say miles per hour. For our next one, it says it takes Liz 2 minutes to type 300 words, and then it says how many words. So that's going to be the top, and then per minute. So that helps me set up my division problem, and we're writing all of our division problems as fractions right now. So she can type 300 words in 2 minutes. That means she can type 150 words in 1 minute. Or you can think of it as 150 words per minute. Our next example there talks about how many miles Mary is running. So it says Mary can run 3 miles in 24 minutes. Then it says how many minutes does it take her to run 1 mile. So instead of the word per here, we see 1, and that's going to tell me the same thing. So right now she's doing 24 minutes of running, and she can do 3 miles or run 3 miles in that time. That means I'm going to get 8 minutes for 1 mile, and we would probably say per mile there. So she takes her 8 minutes to run 1 mile. We can also use this for unit price, which just means we're doing unit rate, only there's money involved. So when I'm talking about money, I'm typically going to have the money, the price per pound, or the price per gallon. So the money is usually going to need to go up on the top, and then whatever the other unit goes on the bottom. So we're also going to divide to find that. And where have you seen this before? Well, I don't know about you, but I see it at the grocery store all the time. And I actually will go and look at, on the stickers at Kroger's, if you look, it'll have like the big price, the price for the whole box or whatever, and then it'll say like the price down here per ounce or the price per bar. And that's how I can tell if like the bigger box is the better value than the smaller box or vice versa. So that's how it's helpful for me. I'm always looking for the better deal until I win the lottery, and then I won't have to worry about it so much. 4 gallons of gasoline costs $16.80, and this is what is the price per gallon. So I'm going to do price per gallon. And like I told you, that's typically how they're going to write it, with the money on top and then the other one on the bottom. It doesn't mean that they can't switch it or that they won't switch it to see if you are reading carefully, especially on digits or things like the air test. So just make sure you read thoroughly. Don't rush through stuff. I'm going to divide by 4. So 16 divided by 4 is 4, and 80 divided by 4 is 20. So I got 4.20 per gallon. That is some expensive gas. We must be in Europe. So $4.20 per gallon. What is the price of gasoline in terms of gallons per dollar? And so that is what I'm talking about. Now they want to know gallons per dollar. Now when I write this out with words, you're going to notice it's the reciprocal. So they're asking me for the reciprocal. So now I want 4 divided by 1680. Now if your answer happens to be a fraction, this is very easy just to flip it. Since our answer is in decimals, and I'm going to get a really long, obnoxious division problem there. With rounding, it's 24.24 gallons per dollar, when your brain's just used to doing it one way. So 0.24 24 hundredths of a gallon per dollar. So I'm getting less than half a gallon. I'm getting about 1/4 of a gallon per dollar. Now on the back, there is some partner practice that we would like you to do. And I'm going to do just the first one. It says Ed drives from Jefferson to Holden, a distance of 250 miles. I have a feeling it's going to be important, so I'm going to put a little box around it. He then travels on to Paxton, which is 25 miles from Holden. And I'm already thinking I might draw myself a little picture here. Just because he's going from Jefferson to Holden. So that was 250 miles. And then he goes from Holden to Paxton, which is another 25 miles. And it says it takes him 5.5 hours to complete the entire trip. How fast is he traveling? Well, first of all, I need to figure out that the whole trip is 275 miles. And it says he's traveling at a constant rate of speed, so we're going to be doing miles per hour. Think about what you see on the freeway, miles per hour signs, how fast you're allowed to go. So if that took him 5.5 hours, that means I'm going to do 275 divided by 5.5. And just a little refresher when I'm doing those division problems. So now I've got 55 into there. My decimal will be there if I need it. 55 into 275. I'm going to try 5 and see if that works. 5 times 5 is 25. And 2, I think we've got a winner here. 25, 27, 0. Now that can go in there 0 times. So he is traveling 50 miles per hour. So good job. Ed is probably not speeding that. And that's his average. It doesn't mean that's how fast he's going the whole time, but that's how fast he goes as an average. So you're going to try the rest of these problems with your partner and see how you do.